I'll now give an overview of the BK2120 analog oscilloscope. The various buttons and knobs are placed into categories. The oscilloscope measures voltage vertically versus time horizontally. It's a graph of voltage versus time. It's a voltmeter. All of the time functions are shown there. All of the voltage functions, voltage controls, are shown here for channel 1. Currently the signal is entering through the coax cable into channel 1. The channel 2 voltage controls are shown here. The vertical mode buttons here, trigger level and coupling sources here, focus knob, trace rotation and intensity here, and the power switch is here. I'll now explain the volts suite, the volts per division knob, the variable knob, the input signal position, the ground AC and DC positions on that switch, and the position. All of those are related to the voltage setting. The function generator signal enters through the coaxial cable into channel 1. In the ground position, that signal is blocked. It's not entering the oscilloscope. In the AC position, the AC part of the signal only is displayed. In the DC position, both the AC and the DC parts are displayed. If you switch between AC and DC and the signal is not exactly the same, it means that there's a DC component which can be measured. The amount of voltage is determined or can be measured by this setting. Currently, the setting is 2 volts per division. A division is 1 centimeter vertically. Remember, this is a graph of voltage versus time. Voltage is vertical. So the division is 1 centimeter. 2 volts vertically is 1 division is 2 volts vertically. So because this is a little over 1, 2, 3 divisions, that means the amplitude is a little over 6 volts. How much over? Well, because there are 5 subdivisions per division, each one is 2/10 of the whole division. So 0.4 volts would be represented by one of the smallest divisions. So that's approximately 6.4 volts. The number here, volts per division, allows the voltage to be measured vertically. And these numbers are meaningful only if this knob is turned fully in the direction shown. In this case, it's counterclockwise. It's critical that this knob be turned fully in that direction in order that these numbers mean something. The last knob is this one, which allows the vertical position to be established. A good setting is to ground the input signal and then center the trace. So that explains all of these knobs relative to the voltage. It may be that the trace is not perfectly horizontal, in which case the trace rotation screw needs to be turned. With a small screwdriver, you can adjust so that the trace is perfectly horizontal. That explains the trace rotation setting. Of course, the intensity can be varied. The smaller the intensity, the more accurate the reading. And of course, the trace needs to be in focus. Small intensity, the better. I've added a second signal going into channel 2. Channel 2 works just like channel 1. These knobs affect the switching between the two channels, and the triggering on the two channels are controlled here. This knob in the out position is the normal position. If I depress that knob, then channel 1 signal is inverted. I can switch between channel 1 and channel 2. Channel 2 is not synchronized with the trigger. It's not triggering on channel 2. It's triggering on channel 1. I can trigger on channel 2 so that the signal starts at the same place on the left. I can see both signals at the same time and trigger on channel 1 or channel 2, or alternate the triggering, one then the other. Trigger position or trigger level can be adjusted within a 90-degree range approximately by turning this knob. I'll now explain the XY button. Currently I have a 10 Hz signal coming in channel 1. Coming in channel 2 is almost the same signal. I can see them both at the same time. At the moment they're almost 180 degrees out of phase, but they're not exactly the same frequency. You can see them shifting slowly. At the moment, they're exactly in phase right now. If I press the XY button, we see what's called a Lissajous figure. That is, the Y channel is being plotted vertically and the X channel is being plotted horizontally. The two signals are plotted against each other, relative to each other. And as the phase shifts very slowly, then the Lissajous pattern changes from a perfect circle to an ellipse. It becomes interesting if I allow channel 1 to become a triangle function and channel 2 to also become a triangle function. So the two signals are being plotted relative to each other when the XY button is pressed. The knobs and buttons relative to time are shown in this section. It works similar to volts per division. That is, these numbers, 2 milliseconds per division, refer to divisions horizontally. Remember, this is a graph of voltage vertically versus time horizontally. So currently each division or each centimeter horizontally is equivalent to 0.2 milliseconds. And that 0.2 milliseconds is meaningful only if the center knob is turned in the fully cal position. That's fully clockwise in this case. It's very important that this knob be turned into the cal position fully clockwise in order that this number be meaningful. And the X position can be adjusted here. It's recommended that on initial setup that you position the trace so that it starts exactly at that left-handmost position, so that as you change the trigger level, notice that that position, horizontal position, does not change. And that's very handy for adjusting frequency. As I change the frequency of the function generator, notice that that start position does not change.